So for today's lesson, we are going to talk about a shortcut that we can use when solving our right triangles, and it has to do with the Pythagorean theorem. If you haven't already, you need watch the video from yesterday where I talk about the first type of shortcuts. You need to stop here, go back, and watch that because you will need to know the shortcuts for today's lesson. If you did watch the video, then we're going to move on. And what I want you to do first is pause the video here as soon as I've explained the directions. And I want you to find all of the missing side lengths, either by using the shortcut that we talked about yesterday or the Pythagorean theorem. So use one of those two methods to find all of the missing sides. So you can pause your video here, and once you're done, hit resume and I'll go through the process. So the first one is the shortcut from yesterday. We are given our hypotenuse, and so then we can find our short side, which is across from our 30, which is half the hypotenuse. So our short side is 6. Take our short side times square root of 3. That's our long side. Second one, these two sides are the same, so we have 3 and 3. That must mean this is a 45, 45, 90, so our hypotenuse is 3 root 2. Third triangle, we just have two sides, so that means we're going to have to do the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So we have 9 plus 16, 25. So then x is 5. We can do the same thing over here. I'm not going to walk through all the steps because you can do that. Leg squared plus leg squared equals hypotenuse squared. So we have a 10 here. Pythagorean theorem again. 13, 5,000, 39, and 12. So we talked about the first two as our shortcuts for yesterday. These next three, oops, not that one, sorry. These three. Have something in common. They can all reduce to 3, 4, 5. That is one of our Pythagorean triples. And if we look at our next 3, all of those simplify down to 5, 12, 13. So these are called Pythagorean triples. There are 3 positive integers that make the relationship true. 3, 4, 5, 5, 12, 13 are the most popular ones, but they can also be multiples. So like we could multiply these triangles by 2, and 6, 8, 10 is a Pythagorean triple. Or times it by 4, 20, 48, and 52 is a Pythagorean triple. And we can use these by using the shortcut. If we're given two sides, like 2 legs of 3 and 4, we can say that the hypotenuse is 5. We can skip that extra work with doing the Pythagorean theorem. So we have 5 problems here. I want you to find the missing side lengths by using your 30, 60, 90, 45, 45, 90, and your Pythagorean triple shortcuts. So pause the video here and work out the problems, then you can check back. So you should have found your side lengths. So this is our 30, 60, 90. Our hypotenuse is 12. So that means our short side is 6. Our long side is 6 root 3. If we look at our second triangle, that is a Pythagorean triple. So remember, we have the 3, 4, 5, 5, 12, 13. 18 and 24, neither of them are multiples of 5, so it's not the 5, 12, 13. It's got to be the 3, 4, 5. 3 times 6 is 18, 4 times 6 is 24. So then our hypotenuse is 5 times 6, which is 30. Our next triangle should be a 45, 45, 90. So our two legs are the same. Our hypotenuse is our leg root 2. Our next one is our 30, 60, 90. We know the short side is 7. So our hypotenuse is double that. And our long side is 7 root 3. And then our last triangle is a Pythagorean triple. It is actually one of our originals. So we have a 5, 12, 13. On your homework today, I do want you to use your shortcuts. After today, you will not have to, but today it is necessary that you guys use your shortcuts on your homework. If you have any questions, hopefully I will be around during resource hour on the Timmer's Help. Otherwise, you can email me anytime. Okay?